Thanks. Thanks everybody for joining. So this is Ning from Intel. So today it will be my pleasure to share our experience on leverage one intelligent unit level test generator to help our ULT development and quality enhancement. So in this session, we will cover 3 topics. First one is the ULT development challenges. Second one is the auto test coverage recommendation system. The third one is the auto test code generation. So as we all know, unit level test has been widely recognized as one important approach to improve software quality, as it can expose bugs earlier during the development phase. But on the other way, in our team, actually we face big challenges on ULT development. So firstly, I would like to have a brief introduction about the software we are working on. So I'm come from Intel's media team. My team owns the media driver development for Intel GPU. So our code base is around 1.6 million lines of code. To cover this big, large-scale software, actually, we need development ULT for maybe around 400,000 lines of code and maybe 8,000 test cases. So as we can find, this is a big number, which means the big effort on ULT test and the maintenance development, all those kind of things. This is one challenge. I think the second challenge is how to identify the error-prone logic deserving higher coverage, because definitely we cannot afford to apply the best test coverage for all the logic. Usually, we only will choose those maybe critical logic and the most error-prone logic to apply those kind of test coverage. But those kind of critical logic selection, actually, they highly depend on the experience. So how to best select those kind of maybe critical logic is a big problem. So that's the motivation for our intelligent ULT generator system design. So basically, so the design target, we have 2 design targets. First one is error-prone logic inference. We want to use one system to automatically identify the key logic deserving more tests. Second design target is about the auto ULT test code generation. This can greatly reduce the effort from development side. That can help the developer to auto-generate the ULT test code and help them to focus on the test case design. So I think this is essential of our ULT development. We always want our developers, they can focus on the quality assurance based on the test code instead of based on the test case design, instead of to spend most of their time to develop the redundant test code. So as a left side, this is a brief introduction about the overall architecture of our intelligent unit level test generator. So actually, this system is based on our client-server design. So as a server side, we have an auto error-prone logic detection and the ULT test coverage recommendation system. It will do the automatic error-prone logic detection and the ULT test coverage recommendation for the developers. And then as a client side, as you can find, so the client side's responsibility is mainly focused on the auto ULT test code generation. So next, let us have a brief introduction about the server side design. So as server side, from the top diagram, it shows the data flow of the server side. So I think the detailed steps can be described as below. As the first step, from the left side, you can see the for our automatic ULT framework, it will regularly poll the bug system for recent bug status. For each new bug, it can get the culprit commit ID from the bug system. And then with the culprit commit ID listed in the bug, the automatic ULT framework will query for the code repo about the components and code blocks impacted by the culprit commit. Meanwhile, from the build system, the auto ULT framework will get the current ULT coverage status per each component and code block. Then, by querying the internal database, the automatic ULT framework can generate the trend for bug versus ULT coverage for each component. So at the backend, as you can find, so let me just use the cursor. Oh, sorry. Let me just use the cursor. So as you can find here, so this is one pre-trained machine learning system against TensorFlow. It can deliver the inference from the training data, get in last step, and generate the recommendation of the optimal ULT coverage for each component. So then, on the client side, actually, so the client side will automatically query for the updated ULT coverage recommendation every time when it is launched. If any test coverage improvement is required for the new recommendation, those kind of information will be highlighted at the client side. So the working flow of the machine learning based inference ULT actually coverage recommendation mentioned above can be shown by the bottom left diagram. Actually, you can see the ULT coverage recommendation system. Yeah, actually, we will have a pre-trained maybe recommendation system, and it will be based on the TensorFlow, and we have maybe quite a few features extracted to support those kind of machine learning. So basically, they are the coverage, the complexity of the current code, the lines of code. So for this modification, whether it is impacts the related components, and if any bug is reported, whether this component is related to the bug, whether maybe the fix maybe not directly related to this component, but it also has some interface change, which can have some coupled relationship with the current component. Also, this is about the bug. Also, we have the corresponding information also reported for the fix. So yeah, I think this is the introduction about the server side test coverage recommendation system. So basically, we can find. I think we use one maybe machine learning system to do the error-prone logic. Also for the inference, and also we will provide our recommendation to our developers for the correct or recommended test coverage for each component. So then next, we will have a brief introduction about our client side, that is auto ULT code generation maybe system. So before we introduce the client side auto ULT generator, let us start from the maybe some introduction about the maybe our ULT code specialty. So why we think it is feasible to auto generate the ULT code? It is mainly caused by the ULT code specialty. Usually, generally speaking, comparing to the driver-error test, the ULT has some maybe very obvious specialty. Firstly, it is of simple logic. And also, we find actually the ULT is of fixed pattern. Maybe the below diagram shares one typical example of the ULT and the class and the test. So here you can see if this is a class and test, let us just call it a class A. So this is what we need to test. As you can find, maybe it has some external dependency to another class called class C. So to develop a ULT, what we need is actually you need one maybe test fixture classes. This is called a test case. This is a test fixture. And the second one when we need to develop is a test case class. This is a test case class. And also, if you want to apply the test successfully, you also need the mock test. This is a mock class. So let us see how those kind of maybe newly developed test code looks like. Yeah, as you can see, this is let's say this is our class and test. It is very simple. It has several functions and also several variables. Then from the test feature side, what you need is you need to have some maybe corresponding test methods developed according to the maybe functions you want to verify. Also, at the mock side, if you have several variables which has external dependencies, at the mock side, you also only need to have those kind of variables implemented in your mock. So as you can see, those kind of maybe actual code, I mean the class A and the class C, they highly depend on the class and the test, and can be easily deduced from the class and the test. So this is our logic. So because those kind of maybe code, newly developed code, they are highly dependent on their class and test. So it will be feasible for us to do the auto test code generation. So yeah, so this is some basic introduction. This is a diagram of the overall auto ULT test code generation system. So for the red blocks, because I would say not 100% of the code can be auto-generated. To promise the ULT test generated, they will be efficient and effective. Actually, we still need some around maybe 20% of manual effort. For the red circles, actually they mentioned the maybe manual effort we needed in our daily ULT development. For other parts, actually they can be fully auto-generated. For the mock class, for the test feature, and for the test class, they can be auto-generated. What our developers they need to do is just to design the corresponding test cases. In that way, we can have our developers focus on the things that really matter. That is the test case design instead of redundant test code development. So till now, so far, we can have maybe over 80% of our ULT code auto-generated. It is over 400,000 lines of code. Yeah. So this is the last page for my presentation. So let us have a brief summary. So big challenges on ULT development for ultra large scale software. Yeah, it is caused by the big development workload of the big scale ULT test code. And usually developers can tend to lack of the focus to the error-prone logic, deserve most coverage. So this is a problem we want to solve. And also to solve those problems, actually we have some design to fix that issue. So firstly, we design a server client-side system. And server side, we will have error-prone logic inference for test coverage recommendation. And then as the client side, we will have the auto test code generation to enable developers to focus on test case design. So that's all for my presentation. So yeah.